Hello students, we are studying practice set 1.2 from geometry chapter number 1 similarity. In previous lecture we studied first three questions of practice set 1.2. Now today we are going to study the remaining questions of this practice set. So we know this practice set depends on the three theorems that we studied in previous lectures: basic proportionality theorem, angle bisector theorem, and properties of three parallel lines and their transversal. So we should know these theorems very well, then we can solve easily these questions in this practice set. So we studied three questions already. Now we are going to study next question number 4. See the question: measures of some angles in the figure are given. Prove that AP upon PB is equal to AQ upon QC. Now from question, if we read question, we can understand this base of this question, on which theorem this question is based on. So as we have to prove this ratio AP upon PB is equal to AQ upon QC. So we know this type of property based on the theorem, that is basic proportionality theorem. Okay, so here we have to use that property or theorem, basic proportionality theorem. But for basic proportionality theorem, we know there is a line parallel to the one side of triangle, and then that basic proportionality theorem is applicable in that triangle. So here first we have to prove that central line, that is line PQ, this line PQ is parallel to line BC, because it is not given in the question. So we have to prove that line PQ is parallel to line BC, and then we can apply basic proportionality theorem, and then we get this answer. So for this we studied in the 9th standard about parallel lines and their theorems and their test of parallel lines. So two lines are parallel when the pair of corresponding angles between them is congruent, then that two lines are parallel. There were three tests for parallel lines: corresponding angle test, alternate angle test, and interior angle test. So we have to use that test here and prove that two lines are parallel. Now see in figure, now we can see this angle P is equal to 60 degree, and this angle B is also equal to 60 degree. Now tell me which type of these two angles, angle P and angle B. So if we draw separate figure for this, suppose this is line PQ and this is line here BC, line PQ and line BC, and this is line here AB. Here is point A, here point P, and at this point here is point B. Now if we draw figure like this, then we know this type of angles or these pairs of angles are known as the corresponding angles. Okay, so such type of angles are corresponding angles, and the theorem is that when corresponding angles are congruent, then that two lines are parallel lines. So here corresponding angle, this P and B are corresponding angles and both are same, that is 60 degree, therefore they are congruent. And if corresponding angles are congruent, then that two lines are parallel lines. So from this we can say this PQ is parallel to BC, and if lines are parallel, then we can apply basic proportionality theorem in the triangle, and therefore we get AP upon PB is equal to AQ upon QC. So see the solution of this. So in triangle, here angle APQ is equal to angle ABC is equal to 60 degree. It is given in the question in the diagram. Therefore angle APQ is congruent with angle ABC. Therefore this side PQ parallel side BC, and reason is corresponding angle test is the reason for that, because if corresponding angles are congruent, then that two lines are parallel lines. Now this line is parallel, PQ is parallel to BC, and therefore we can apply basic proportionality theorem, and therefore we can write AP upon PB is equal to AQ upon QC, and reason will be according to basic proportionality theorem. So thus we prove this by basic proportionality theorem. Okay, then next question number 5. So in a trapezium ABCD, side AB parallel side PQ, parallel side DC. So AB is parallel to PQ and PQ is parallel to DC. So three lines are parallel lines. Some measurements are given: AP 15, PD 12, then QC is given, QC is 14, and we have to find BQ. So simple question here, and question is based on three parallel lines and their transversal. We know that theorem, we studied well that theorem, and we know formula of this also. AP upon PD is equal to BQ upon QC is the formula for such type of theorem. So see the solution. So side AB parallel PQ parallel DC is given, and therefore we can apply property of three parallel lines and their transversal. So according to this, we have formula AP upon PD is equal to BQ upon QC. Now put values of this. AP is equal to 15 divided by PD is equal to 12, and we have to find BQ. So BQ as it is divided by QC is equal to 14. Now this 14 become multiplied to the left side. So BQ is equal to 15 into 14 divided by 12. Now simplify this. Simplify this one. So we can divide 15 and 12 by 3. So 3 5s are 15, 3 4s are 12, and into 14 as it is. Now simplify this one. 2 2s are 4 and 2 7s are 14. Okay, now 7 into 5. So 7 into 5, 35, and divided by 2. So 35 divided by 2, 2 1s are 2, remaining 1, 2 7s are 14, again remaining 1 point, then 10, and 2 5s are 10. So answer is 17.5 units. Okay. So simple question was three properties of three parallel lines and their transversal. Then question number 6. Find QP using given information in the figure. Now when we see the figure, we can understand the formula or theorem. Now here this angle bisector is given NQ, and we can say this is angle bisector because this angle N divided into two equal parts. This signs, from this sign here small 0 is written. So from that small 0 we can say here these two angles are equal. Same sign, then that two angles are equal, and if two angles are equal, then this ray NQ is bisector of that angle. Okay, then we can use here angle bisector theorem, and we know that theorem. So if we take here Pn upon Nm is equal to PQ upon Qm, or we can write in opposite direction Mn upon Np is equal to Mq upon Qp. So in any method we can use the formula. So we have to find QP. Here this QP we have to find, and the remaining sides are given. So this is based on the angle bisector theorem. So in triangle MNP, segment NQ bisect angle N, and it is given. Now why given? Because in diagram this same sign indicate both angles are equal. So here by property of angle bisector of triangle, here we have the formula Pn upon Mn is equal to Qp upon Mq. So put the values. Pn is 40, then Mn is 25, Qp as it is, and divided by Mq is 14. So this 14 become multiply to left side, then this is equal to 40 divided by 25 into 14. So divide by 5 to 40 and 25. So 5 8s are 40 into 14 as it is, and 5 5s are 25. Then multiply by 8 to 14. 8 4s are 32. 8 ones are 8 and 3 11. So 112 divided by 5. Again simplify, divide by 5. So 5 2s are 10, remaining 1. Again 5 2s are 10 point, so remaining is now 2, and if we take decimal point then we can take here 0. 5 4s are 20. So here answer become 22.4 units. Okay, based on the angle bisector of triangle. Next question, question number 7. In the adjoining figure, if AB parallel CD, CD parallel FE, then find X and AE. So in figure we can see here is X and AE, so total distance AE. So we can write AE is equal to AC plus CE, and CE is nothing but X. So if we find X, then we can easily find AE. So for finding X, we can understand this figure based on the theorem 3 parallel lines and their transversal. In question already given that AB parallel CD parallel FE, that is 3 parallel lines. 3 lines are parallel and it is given. So we can directly use here property of 3 parallel lines and their transversal formula. So line AB parallels line CD, parallel line FE, it is given. So we can use formula, that is BD upon DF is equal to AC upon C, or we can write AC upon C is equal to BD upon DF. So put the values. BD is 8, DF is 4, then AC is equal to 12, and divided by C, C is X. Now this X become multiplied to the left side, so X into 8 upon 4 is equal to 12. Then we can write this X is equal to this 12, and this divide 4 become multiply, so 12 into 4 divided by 8. Now simplify this one. So 4 2s are 8 and 2 6 are 12. So here X is equal to 6. So X becomes 6. So this length X is 6 unit. Okay, so this is half question. X is equal to 6. Then we have to find AE. So we know AE is equal to